Time for page 3. And we're simply simplifying some more fractions here. For the coefficients, I could divide both numbers by 11. That would make us a 3 in the numerator and a 2 in the denominator. Larger power of x is in the bottom. 5 beats a negative 1. Now be careful here. It's 5. Subtract negative 1. Take away negative 1 becomes add positive 1. So we get 2x to the 6th. And there is no y on the top. We don't want this negative exponent y. So like I said a few minutes ago on page 2, just bounce it across the bar and change the sign of the exponent. What's going on invisibly there, and I'll write it, is multiplying the top and bottom by y to the positive third, which makes a y to the 0 equaling a 1. See, there's a 1 there that we don't bother to write. And we get a y to the positive third up on top. Let's go down to this. Can we divide both of these by 7? And that would make a 5 and a 3. Where does x go in the answer? On top. 4 take away negative 2 becomes 4 plus 2. Negative 3 is not as far below 0 as negative 4. So negative 3 is the bigger power. It stays in the bottom. And negative 3, take away negative 4, changes to negative 3 plus the opposite, positive 4, which adds up to 1. That's a y to the 1. We don't bother to write the exponent 1. And what's bigger, negative 1 or negative 7? Negative 1. So we keep the z in the top. And negative 1, take away negative 7, is equivalent to negative 1 plus the opposite, positive 7, which adds up to 6. There's our answer, 5x to the 6th, z to the 6th over 3y. Now go to the top up here. Everything in here is to the second power. So it's 7 to the second power is 49. Power of a power, we multiply, we get x to the negative 4. And w to the positive 6th. And the only thing lacking in our answer is we don't want to have this negative exponent. So here's an easy way to deal with that. Make this a fraction by doing that. And then just pop that across the bar. So we still have the 49 w to the 6th on top. And now we have x to the 4th in the denominator. Okay, again, I can justify this by saying multiply the top and bottom of this by x to the positive 4th. You'll get an x to the 0 up here, and you'll get the x to the 4th down there. Order of operations takes hold here. You got to do this exponent and this exponent before you multiply. Please excuse exponent. My dear, exponent before e before m, exponent before multiply. That's enough said about that. Let me just do it. Everything in here is to the second power. Negative 3 squared is positive 9. That's going to be x squared. And y to the negative 4, multiplying the exponents there. And this is going to be x to the negative 12. And if I multiply the x terms together, 2 plus negative 12 is negative 10. So here's my answer so far. I need to get these negative exponents to go away. So I'll do that same thing I did in the one before. Make a bar and a 1 and pop these both across the bar and change the sign of their exponent. When we're done with that, all that's left on top is the 9. And we have an x to the 10, y to the 4 in the bottom. Okay. The other topic in today's objective is scientific notation. And you might remember scientific notation, but I'm going to assume you've never seen it before. We have a number times 10 to a power where the number here, the a, has to be a number between 1 and 10, its absolute value between 1 and 10. In other words, it has to be a number that has a single digit and then a decimal point and then however many other digits you need. But just exactly one digit there and not a 0. 1, 2, 3, 4, 5, 6, 7, 8, or 9 has to be there, or negative 1, 2, 3, 4, 5, etc. Okay? And the exponent has to be an integer. So, and here's spelled out a little more carefully. A single digit there, a decimal point, a few other digits as needed, times some power of 10. And what's handy about this system is whatever the exponent is here means that if we would get rid of the scientific notation and write the number the ordinary way, all we would have to do is get rid of that, get rid of the 10 to the power, and instead move the decimal point n places to the right if n is positive, or to the left if the exponent is negative. So, first thing I want to do is look at these and say, are they in scientific notation or not? So this first one, we've got a single digit, a decimal point, and then one more digit times a power of 10, and that is an integer. 4 is an integer, so that's scientific notation. This one is not in scientific notation because it's 32. You know, it's really like 32.0 times 10 to the fourth. And we've got two digits in front of the point, so that's no good. We're supposed to only have one digit, so let me move the point here. Now, since I moved the point one place to the left, a moment ago, the point was supposed to go 4 places to the right. Now, I pushed it in the wrong direction, one place. Now it needs to move 5 places to the right, so that fixes it. So these are equivalent, but this is in scientific notation because I have just one digit in front of the decimal point. A single digit before the point times an integer power of 10, that's okay. And this one's not okay because I don't have, the digit can't be a 0. So I got to change this. I'll make this 3.2 times 10 to the, now, originally the point was supposed to go 4 places to the right. It was right here. It was supposed to go 4 to the right. I moved it over 1 place to the right. I took care of one of those moves, so we knocked that down to a 3rd power of 10. Okay, and if you don't see that these are equivalent, put these in the calculator. If you do 0.32 times 10 to the 4th power, 0.32 times 10 to the 4th power, see that? 3,200. Now if I do 3.2 times 10 to the, what did I change it to? 3.2 times 10 to the 3rd power, I should still get 3,200, and I do. See, I'm not lying. And is this in scientific notation? It's got, this part looks good, but this 1.4 isn't an integer. So no. And this one can't be fixed, not by any ordinary means anyhow. Remember, integers are the numbers 1, 2, 3, etc., going forever, and the number 0, and the numbers -1, -2. So these are the integers, the numbers you would count chairs with, and 0, and their opposites. No decimals, no fractions. Okay, that's the end of page 3.